Hello, welcome to online course on speed control of DC shunt motor. This open educational resource is created for the partial fulfillment of pedagogy for online and blended teaching learning process faculty development program conducted by IIT Bombay. This course is prepared by myself, N. Vijayalakshmi, Central Polytechnic College, and Mrs. K. Urmila, AMK Tech Polytechnic College. Now let us see the contents of this class. In this class, I am going to cover what is speed control. Why is it necessary to control speed of a DC shunt motor? How can we control the speed of a DC shunt motor? These are the three topics is going to be covered in this class. What is speed control? Now let us see the nature of an electrical motor. Electrical motor is coupled to a mechanical load. This mechanical load varies with respect to time. With respect to time, the load decreases, increases, decreases. It is variable in nature. With respect to load, most of the electrical motor, the speed of the electrical motor changes. Even though it is a DC shunt motor, it is having slightly drooping characteristics with respect to increase in load. DC shunt motor is called as constant speed motor, though it is having slightly drooping characteristics with respect to load, increase in load. Now, what is called speed control? Can we call this as speed control? When we increase the load, the speed of the motor decreases. Can we call this as speed control of the motor? No, this is not a speed control of a motor. Speed control is keeping the speed of a motor constant, independent of the load, irrespective of the load. Whatever may be the change in load with respect to time, the speed of a given electric motor should be kept constant at the required speed. That is called speed control. Now, why is it necessary to control the speed? As we know already, our electrical motor is coupled to a mechanical load. This mechanical load is variable in nature, and this mechanical load may be used for different applications. It may be used, it may be the shaft of an elevator or escalator. It may be a shaft of a motor used for industries, rolling mills, ball rolling machine. This different type of application requires different range of speed. One time it may be required to operate at one speed. At some other time we may require the same motor to operate at different speed. So it is necessary to control the speed of the DC motor for any particular application. we can conclude like this. Precise speed control is necessary to make a motor suitable for a given particular application. Now let us see how can we control the speed of a DC shunt motor. In industries, we use induction motor, synchronous motor, DC shunt motor, DC series motor, DC compound motor. Whatever may be the motor, we need to control the speed of the motor. In this class, we are going to study the speed control of DC shunt motor alone. Okay, let us see the circuit diagram of a DC shunt motor. This is the armature of a DC shunt motor. Here inside I have shown the equivalent circuit of the armature. Armature generates back EMF, that is EMF which is more or less equal to this voltage, supply voltage, but in opposite direction. And this is your armature resistance. So equivalent circuit of a DC motor's armature is EB in series with armature resistance RA. In this circuit, take this loop and apply Kirchhoff's voltage law. This is potential rise V and these two are potential drops. So sum of potential rise is equal to sum of potential drop in case of KVL. That is V is equal to EB plus IA into RA. Okay, this is about armature circuit. Field circuit. Field circuit is connected to a constant voltage source V. The current through the field coil is IF. The field current IF produces magnetic flux in the DC motor, main magnetic field. The flux is we use a symbol phi for the flux. This is the main magnetic flux. Whenever we change the current flowing through the field coil, the flux also changes. Now, what is the relationship between this speed, flux and back EMF? Back EMF is nothing but it's proportional to N into phi. Now, you can make the equation like this. N is proportional to EB divided by flux phi. What is EB? EB is nothing but this V minus IA into RA. So, this equation will be like this. Speed of a DC motor N is equal to V minus IA RA. Instead of EB, we are putting the voltage equation divided by phi and K is the proportionality constant. Okay. Now, the speed of a DC motor depends on the supply voltage, drop in the armature circuit, magnetic flux phi. Now, pause this video for a second. Think of various means to control the speed of this DC shunt motor and write it down in your course journal. Pause this video for a minute. Yes, let us now see the various ways to control the speed of a DC shunt motor. From this equation, we come to know if you change the flux, the speed of a DC motor will change. the proportionality is inversely proportional. That is, if the flex increases, the speed decreases. If the flex decreases, the speed increases. So, by adjusting the current through this field coil, you can adjust the flex and hence the speed. If you control the speed of a DC shunt motor by means of controlling the flex, we call this method as flex control method. What is the other way to control the speed? You can control the armature circuit drop. We cannot change the armature resistance RA, but we can introduce a resistance in series with RA. We can introduce an external resistance in series with RA so that armature circuit resistance can be increased. If you increase this resistance, the drop in armature circuit increases so that EB, which is V minus IA or A, decreases. If this numerator decreases, the speed also decreases. So, if you introduce an additional resistance in the armature circuit voltage drop increases, which reduces the numerator of this equation, which reduces the speed in proportional. To control the speed, if you adjust the armature circuit resistance, we can call this method as armature control method. Another way of changing the speed of this machine is by adjusting this voltage. Though most of the cases this voltage, supply voltage, is a constant, we can find some means of having variable supply voltage. If you find some means of changing this voltage, you can change the speed. This method is called voltage control method. In the forthcoming classes, Mrs. K. Urmila is going to deal about flex control method and armature control method. And myself, Vijay Lakshmi, is going to deal about voltage control method. See you.